Hello and welcome everyone to responding to unauthorized configuration changes using opConfig and opEvents. My name is Mark Henry. I'm a senior engineer with opMantic's North American office located in Charlotte, North Carolina. Today's subject is one that really kind of excites me. As a working engineer myself, anytime I can improve the quality of my network monitoring, my event creation, anytime I can automate troubleshooting or automate event response, really, it saves me overhead, it saves me time, it empowers me with more information, and it also helps improve the quality of life for the customers that the IT department is servicing. So in today's session, we're going to cover some really detailed material, and I think you'll enjoy it. As a reminder, everyone, if you're joining the live webinar, we will be sending out an email afterwards with a link to the video. If, however, you're on the opMantic YouTube channel, or if you've come to the opMantic website, to our learning portal, you should be able to find all of your materials there. If you have questions, please feel free to submit them to the questions panel, the Q&A panel in GoToWebinar. We do have a team who will be monitoring that. We do have a lot of attendees live in today's webinar, so if we don't get to your question, we'll try to respond to you offline following the webinar today. At the end of the webinar, or if you leave early, there is a very short exit survey. It's only 3 questions. It asks you what you thought about today's topic, what other topics you might suggest, and how I might improve as a speaker myself in the way that we deliver webinars. So we do really value your feedback. We act on it, especially on how I can improve, but also how we can improve the webinars moving forward. So please feel free to answer those questions as you exit today. So what are we going to cover today? Really, it's going to be a very focused 30-minute session. We're going to talk about how to configure opConfig to collect device configurations and raise alerts to NMIS. And then we're going to talk about how NMIS can take can take response to that. So if you are using opConfig and NMIS alone, how NMIS can take response to those and notify people through its escalation policy. And then we're going to talk about how you can leverage opEvents and opConfig to push configuration changes back to devices, or simply do troubleshooting and remediation steps with opEvents based on configuration changes that you've seen from opConfig. So again, a lot of discussions about system automation today. I always like marrying these topics back to Gartner's IT Service Management Maturity Model. This really is just, it's a simple, straightforward layout to try to understand where your IT department, where your MSP business, your ISP business is in the way that it provides services to its customers base. So generally speaking, a lot of the customers that we talk to who haven't adopted NMIS or NMIS as their network monitoring solution are sitting down around the level 0 or level 1 area. That's also the same for many kind of low-end, off-the-shelf or free or open source monitoring solutions. But once you start looking at opMantic's NMIS, once you roll in opConfig and or opEvents to that, you really help propel yourself solidly into level 1, moving into level 2 with how you can automate responses, how you can do mature problem configuration change and asset management. It shifts you more into an IT as a service provider rather than just a firefighter. It also allows your group to be able to guarantee SLAs, integrate multiple processes back and forth, and gives you a bit more real-time infrastructure, especially if you're, like the example we're going to show you today, monitoring devices for configuration changes, generating events from that, and then automatically responding to those events and pushing new configurations back out to your devices. So we'll be taking a look at that stuff today. So what parts of the puzzle out of opMantic's solution set focus on today's challenges? So we've got from the open source side of opMantic solution set, you have NMIS, which is our core performance and fault monitoring solution. You also have opConfig, which is one of our commercial solutions that bolts into NMIS and handles capturing, tracking, and pushing configuration changes. So it's a mature configuration and compliance solution. And then you also have opEvents, which again bolts into NMIS. And it is an advanced event management and response system. Some people refer to it as a manager of managers. That's fine if you want to take that approach. At the end of the day, for me, it's the ability to create custom rule sets that handle troubleshooting, that handle event remediation, that do event deduplication, handle event storms, all of that kind of stuff. So it's much more even than just an advanced event management system or a manager of managers. So some useful references for you. Again, if you're watching this, if you're live in the GoToWebinar, you can download on the handouts panel of your GoToWebinar page a PDF version of today's presentation. If you're watching this on the YouTube channel, on the opMantic YouTube channel, please come to opmantic.com, opmantek.com, and you can find all of our references under the Learn portal. If you're on the opmantic.com Learn portal now, you should find this as a download at the bottom of the webinar page with this presentation in it. So we have links here to the opConfig wiki, as well as the opEvents wiki. opMantic uses an online wiki system provided by Atlassian's Confluence. We appreciate the Atlassian team greatly for that as well. If you have any questions, you can come to the community questions board at community.opmantic.com/questions. If you are a support customer or if you're doing a proof of concept for opConfig and opEvents, please email our support team at support@opmantic.com. We'll be happy to help you out with your proof of concept, answer any questions you have, get you up and running quickly on a proof of concept, whether you're installing natively on your operating system or using opMantic's virtual machine. Finally, if you have any sales questions at all, please email us at usa@opmantic.com. If you're not in the North America region, our USA team will be happy to refer you to the correct sales group for your location. A few additional references. When it comes to opConfig, we often get questions on how should I configure my devices? What does secure mean? How can I write my own compliance rules? Where should I get my compliance rules from? And so we've put together this list of references for configuration and compliance of networking devices. So the UC Berkeley Secure Device Configuration Guidelines, fantastic starting point. Very easy to read and very detailed. You should also check out the Center for Internet Security as well. Their controls page and their benchmarks are fantastic. Again, tremendously helpful, although they are rather technical in nature once you start getting into some of the benchmarks. The National Security Agency, or the NSA, used to provide really detailed configuration guidelines. Used to see the ones called the NSA Cisco router set or the NSA Cisco switch set. Many of those have been discontinued. You can go to the iad.gov library. Some of them are still hosted there, although many of them have been pulled down because the department that was actually keeping those up to date and making sure that they were maintained has been dissolved. So, check out the NSA configuration guidelines, see what's there at the IAD. Maybe there's something that's helpful, but definitely the UC Berkeley and the Center for Internet Security. All right, so where do you get started, right? Everything starts with monitoring the devices themselves for change. So in order to understand what a change is, you have to have kind of a starting point. You have to have a version 1 of something, of a configuration, and then you have to have another version of that same configuration. You need to be able to compare them together and find the deltas between the two, and then determine if one of those deltas, if that change is something that should be alerted. Is that something that people should know about, right? If it's a date and time stamp that changes, maybe it's not something you want to alert on, right? But if it's a password encryption setting going from password encrypted yes to password encrypted no, and now the password is stored in plain language inside the configuration files, well, that could be a problem, right? We should be raising an alert saying, hey, there's a configuration change here that's not allowed. So looking back at the UC Berkeley kind of requirements, right? Their recommendations. They really have two very, very focused goals for configuration change detection, and that's monitoring configuration changes on covered devices. They should be logged automatically or via established change management processes, right? So if you're going to make changes to devices, you should be able to log it that the change is going to happen, and that there should be an established change management process. And second, resource custodians, meaning people who own the devices or manage the devices, should be alerted when configuration changes are made. And that's really the piece where we step in, right? So Augmantic doesn't have a change management process or change management tool yet, but we do have the ability to monitor those devices and then alert you when a change occurs. And we do that using opConfig. So how does opConfig work? What are the kind of the underpinnings of that? opConfig works just in a straightforward way. It connects to a device using either Telnet or SSH. Once it's logged into a device, it then executes whatever CLI command sets have been recorded and deemed as appropriate for that device based on the device's manufacturer, model number, and operating system version number. So depending on the operating system version and version number, it might be different commands that you can execute, or those commands might be slightly different. Like show running startup, for example, there might be a slightly different format to that depending on the model, manufacturer, and operating system. opConfig keeps track of those differences. It uses a system called CLI phrasebooks. These are all text files. They're open source ASCII text files. They're Unix formatted files. You can open them in any text editor. They stack on top of each other. They're very well documented both internally to the files, but also within our wiki on those references. And you can see down at the bottom, if you go to the opConfig homepage, you can get links to those pages that talk about how to decipher the CLI phrasebooks. We ship with quite a few right out of the box, but they can and should be customized for environment. So you might have devices that we haven't modeled yet. We have complete instructions on how to model those, how to create command sets, and how to create CLI phrasebooks for new devices or new models or new operating systems. We also support the ability to run those command sets, run those CLI collections on whatever cadence you want. Generally speaking, right out of the box, we suggest collecting on command sets that change often, once every hour, and then doing kind of a daily collection on command sets that don't change often at all. You can also create custom kind of collections of commands. For example, I have here on the screen in the middle bullet the idea of having daily, hourly, and troubleshooting command sets. So for example, if something goes wrong with the device, you can say, run all of the troubleshooting command sets on this device, and all of the commands that are marked for that type of device as troubleshooting commands will be run, and the results of those commands will be stored with the event that called that request. You can also call collection on demand. You can do it through a very robust API, and we will touch on that today. A good example of that is automating using opEvents. And we're going to kind of walk through the process in a little bit on how that works, but at a very high level. opConfig runs a collection, sees a change, raises an event to NMIS. NMIS pushes that event to opEvents. opEvents then says, for this type of device or this type of event, I need to run these troubleshooting scripts, which may include running commands, CLI commands for gathering troubleshooting information. So kind of a round robin discussion between different devices or different kind of network monitoring solutions, and then getting back to the device again, collecting additional information and storing it with that event for the engineer. So how does opConfig collection alerting work? So for example, generally speaking, a cron job runs. It might be the hourly, might be the daily. opConfig executes command collections, whether that's again, hourly, daily, troubleshooting, whatever. It then compares the results of the collection to the last result that was stored, and that's on a command by command basis. If it sees a change between, let's say, show running config, the one that's in storage, and the one that was just run, if it sees a change, it'll raise an event. And so for every change, for every CLI command that's run, each piece that is a change is its own event, right? Because you want to be notified about which of these commands have been changed and how they've been changed. NMIS then receives the change event, and opConfig links the results of that kind of command collection to the event in NMIS. So it's here's the device, it's a configuration change event, and here are the details of that, which include a link back to opConfig. So before we get into the kind of the workflow process, let's take a quick look at what opConfig looks like. So the opConfig dashboard is pretty straightforward. Across the top, on the top left, you have all of the nodes that have had changes, and the current filter in place has to be 8 days. So you can see there's a pattern of changes happening here over this period of time. You can see there's a certain list of devices that are here. In the bottom left-hand corner, you have recent config changes. So this panel is identifying not just every command that was run, but specifically which commands produced changes in which devices. And then down the right-hand side, you see all of the commands that were run, what date and time they were run, and then what revision number was completed or assigned to that command. And so, for example, if I look at B&E Lab RR1, show startup config, you can see it's now at revision 4766, and we can drill into that command. And I like to view these side by side. So this will compare the current version 4066 on the right with the previous version 4765 on the left. And if I scroll down, I'll find the change. So here you can see it's IP OSPF cost 999, and then that has been removed from the right-hand side. If I want to, I can compare, let's say, this change with the previous one. So now I'm going to load 4765 on the right and 4764 on the left. And as I scroll down, you'll see the addition of that change. And as we'll see in a minute, this change to the running config of this device, that's actually the result of an event that occurred and a command that was run to change that OSPF cost, which changes the addressing and the routing of events through a specific interface. So we'll look at that more in just a minute. So going back to PowerPoint. So a common workflow, one of the pieces that we're often asked is not just what are the features and functionality of your tools, but how do I use them in a practical way in my organization? So we like to talk about workflows, right? All of Opmantic's solutions are designed to be very, very flexible. So you can actually use the tool and adjust the tool to work with your existing workflow, or you can adjust your existing workflow and adopt some of our suggestions and recommendations. But at the end of the day, they're just suggestions, right? They're not you must follow this path. Here's one way to get to the end goal. So for example, we recommend a 4-step process where when a change occurs, you identify the device, the event, the element, and the priority. That's all done automatically for you by a combination of opConfig and NMIS. A human would then investigate. So you'd look to try to determine, have there been revisions? Is this device in change control? You can also automate a lot of this. So if you're using a tool like, let's say, ServiceNow, and you're using ServiceNow's change control and change management system, you can actually pull from ServiceNow a list of changes, of approved changes today into NMIS, and put those devices into outage during those change management windows. That way, new events aren't created and aren't raised while those devices are being manipulated and changed. So lots of different things you might consider. After you've done your investigation step, we would suggest that you close the event. So you would add whatever comments you have to the comments field. You would then acknowledge the event in opEvents or in NMIS. And finally, as an after action, you would remediate. You talk about why this event was raised, how it was raised, how you could how you can handle this event automatically in the future, what you might do for automated troubleshooting or automated response, how you might automate the idea of putting devices in or out of outage inside NMIS or OP charts based on their status within whatever CMDB system or whatever change management solution you're using. So we've talked about the concept of how opConfig monitors devices, how it gathers and executes commands, how it compares those commands together, and then raises an event that goes from opConfig to NMIS. So how do you respond to that event? How do you do something? So let's take a quick look at kind of the Opmantic application flow. So this is considering a two-tiered approach where you have polling servers along the bottom tier. So those polling servers are, they might be an Opmantic VM virtual machine. They might be your own servers built on your own Linux operating system where you've installed whichever solutions you need. They're reaching out to your subnets, they're reaching out to your devices, and they're monitoring those devices. So NMIS monitors SNMP and WMI. It also processes SNMP traps, and it handles service monitoring all natively. syslog parsing is handled by opEvents. CLI data collection is handled by opConfig, which we've talked about earlier. Both opConfig can generate events that go to NMIS, and NMIS can generate its own events. And those events can then also go from NMIS back to opEvents for processing. So if you do not have, again, if you do not have opEvents, you can use NMIS 8's escalation policies to monitor a device or group of devices or types of devices. So in the example that I have here, we've set up a notification. We are monitoring a couple of different metadata tags. So for example, we're looking at the assigned role of the device. So we're saying all devices that are assigned as core devices. And that's, again, it's just a metadata tag assigned to a device of type router. And NMIS will figure out what kind of a device it is based, again, on its manufacturer, model, and operating system. So it'll figure out if something's a router or a switch, firewall, load balancer, etc. And then we've specifically defined, or we've selected, node configuration change as the event. So for a device in any group, and that's what default means, default really means any group, of role core, of type router, with an event of node configuration change, start this event cycle. So NMIS will start escalating this, starting at level 0. Level 0, if you don't change the escalation levels, level 0 is what we also call time 0, or the moment that the event occurs. So in this example, when the event is first reported, NMIS will generate an email to the help desk and to the on-call technician, whoever those two resources are. And then at level 3, which generally each of these levels is 5 minutes. So you've got level 0 is time 0, level 1 is 5 minutes in, level 2 I believe is 15 minutes in, level 3 is 30 minutes in. So at level 3, you will then, if this event has not been acknowledged, it will then generate an email to the duty manager, to operations, and to the on-call technician again. So you can customize these however you want. It's totally up to you. Very, very flexible system. But what it doesn't allow you to do is NMIS does not allow you to take kind of proactive response to the event. So you can't do something about it other than really the notification methods that are built in. So you can use syslog, JSON email, ccopy, pager, and netsend. Those can be expanded on, but they're rather limited, but it's totally up to you. Note that down at the bottom of this, we have up notify set defaults. That's because a node configuration change is not a stateful event, right? So node configuration change is not going to go from true to false, back to false. It just tells you that something has changed in this device. You can drill into what the details of that change is if you want to, but if someone changes that configuration back, it's not going to give you a down event, right? It's not going to give you a clear event, rather, whether that's an up or cleared to that. It's just going to give you an other node configuration change. So now if this is enough for you, if this is all you want, you can actually stop here. But if you want to take proactive action, you have to really build on this information and expand into opEvents. So with opEvents, you can add things like whitelisting and blacklisting of events. You can handle correlation, deduplication, event storms, event flaps. You can suppress certain events. So you might say, if I see one device and that device is in outage, don't raise any events at all. You might say, if I see a group of devices at the same physical location or owned by the same customer, which have 5 or more change notifications within a few minutes, then suppress those events. So there's all kinds of automation that you can do in event handling at the opEvents level that you can't do in NMIS natively. So how does opEvents process? What's that process? Again, NMIS receives the event. opEvents reads the NMIS event list, the ongoing list of events, the trailing list. It then applies an archive list, so what events should be saved for posterity's sake, what events should be blacklisted, so you can blacklist devices by or events by event, by device type, by customer. So you may have some events that you just don't want to respond to, so you can apply a blacklist. Then a whitelist is applied, which says these are things that should always be dealt with all the time, and certain things that should happen with that. We then correlate events into outages. We deduplicate events. We determine the priority of the event, and that's all done programmatically. And then we conduct any actions. So these are the positive response, whether that's troubleshooting or making changes. And then we start any escalations. So who do we have to email? Who do we have to text message? Who do we have to send a pager alert to, et cetera? So when it comes to talking about event actions, right? So event actions are kind of the proactive responses to an event that opEvents receives. So these event actions, they're very, very flexible and they're extremely powerful. I'm going to flip over now from, again, the PowerPoint. So we have opConfig here. We have opEvents. What I want to do is I want to take a look at what kind of a proactive event response looks like. Oh, one of our engineers is flagging me down, says that we have a question from one of the attendees. So someone has noticed a new column here in opEvents, the links column over on the right-hand side. So very observant of you, yes. So the links column is new in opEvents 2.4.2. That was just released this week, November 2018. So this allows you, you have been able to for quite some time now, define a contextual link inside NMIS for each individual device. That link can literally go anywhere. It can go to any program. It can go to any URL that you want to put into that option. You can do it by device type. There's all kinds of options that you can do. You can assign it programmatically if you want to through the API. But what that allows you to do, for example, is now you have been able to use it in OP charts to great extent. But now that this has been carried over into opEvents, I can actually click on this link and go somewhere. And you can see the little pop-up bubble there, awesome context link example. I'm just going to right-click on that and use my browser's right menu to hit open link in new tab, just so we don't lose this. Here we go, and that's going to load. And I have this set up for this topology map that I pulled up earlier today and saved, and I've just assigned this URL that you see to that contextual link. All right, so back to opEvents again, and I'm going to drill into this event here for this device, for B&E Lab RR1. So I want to drill into that event. This is an event that we actually have the system set up to generate some example events. And then, of course, we have some response scripts that have been written to respond to those events as well. So I'm going to drill into this proactive interface error input packets event. You can see here in the lower middle of the screen, there are several actions taken for this event. One of them is automated, so it was automatically acknowledged. And then there are two scripts that were run. So these are scripts that were run because of the type of event. So there's a test actually inside the event actions piece that say, for this device, for this interface, for this error, and this happens to be a proactive interface error inputs packet on this specific element or interface. So for this device, this element, this event, run these two scripts. And I'm going to show you those in just a moment. But those two scripts have actually run, and they've actually reconfigured this event. What they've done is they've actually run a CLI command that has pushed back a new configuration to this device, and you saw that earlier in opConfig. This has pushed a new configuration to that device. That new running startup configuration changed the priority on addressing and interface usage, and so it's now rerouted traffic off of this device and onto other devices in the network. So let's take a look at what that event actions piece looks like. New also in opEvents 2.4.2 is the ability to edit event actions internally to opEvents. Previous to version 2.4.2, you actually had to go to the Linux command line of the server, go to a specific folder, open the event actions file, and then edit it manually by hand. So this now adds a live JavaScript editing engine. It adds live color coding, tagging. We have built-in help down the right-hand side as well. This feature, our plan is to add this type of feature to every other kind of manually edited file that we have that previously you would edit at the command line. We're looking to add this over the next several releases. So at this point, what I can do now is I can actually look through these policies. So these policies are rule sets that are running. You can see the rule set here, rule set number 40. So event.node equals BNE-lab RR1, event.element equals Ethernet 1/2, and event.event equals proactive interface error input packets. Now we were very, very specific in this event just because we didn't want our demo system pushing configuration changes willy-nilly across all of the demo network. So we wanted this to be specifically something that we could control and watch and monitor. So you can be more generic. So for example, this could simply match on just proactive interface error input packets and then reroute just that device. You can see here, we're calling out to two scripts. Script BNE-lab RR1 EL2 route not and P2 FA00 route not. If I scroll down past all my policies, I will eventually get into my scripts. So lots of different things that you can control here in opEvents, including logging. So you can see here we've got a couple of different ways of logging pieces. In scripting, you can see here that we've added some troubleshooting scripts. So MTR node, trace route node, ping neighbor, troubleshoot BGP, etc. And if I scroll down to the bottom, you can see that we've got those two scripts that were referenced by the policy earlier. And here what we're doing is we're actually calling out to the opConfig CLI. So we're using the opConfig CLI. We're telling it, we're passing it a list of arguments. We're saying push config set. We're giving it a name of a configuration, a config configuration that's already been uploaded into the opConfig system. We're telling it when to do that at now plus 1 minute. And we're telling it what nodes that should affect. So you can actually push config changes to a list of nodes rather than just an individual node. So just an example for you to give you something to think about. Again, we ship with many of these. We have a lot of them written up, examples written up on the opConfig and opEvents wiki as well. We're always looking to add more examples up there. If this is of interest to you and you're looking to try this out in your environment, do a proof of concept, again, reach out to support@opmantic.com. We'd be happy to engage with you and help you run a proof of concept and show you how these systems all work together. Switching back over to the PowerPoint. So this just reiterates a bit of what we've done here. So this is more of a generic example rather than the very specific one I just showed you off our demo server. So example here is node.role-type equals core, and node.type equals router, and event.event equals node configuration change. So, for example, you might have a script called reset router config, and what it does is push a generic or approved or kind of gold image router configuration back to the device. So if anything changes, roll the device back to the approved configuration. And of course, you could be even more specific. So you might say node dot operating system equals Cisco OS X version 12.3.5. That's why you can be as specific as you need to in which commands are executed and how they're executed and what happens to them. And you don't have to run these policies right away. You can actually escalate these policies. So you could say, I want to run this policy in 20 minutes if no one acknowledges the alarm. So if someone acknowledges the alarm before then, great. If not, I want to force push a new configuration or the approved configuration back to the device again. Lots of options that can be done there in opEvents. As far as sequencing and escalations go, it's almost infinite. Happy to have those conversations with you and help train you and your team on how to walk through them and how to work through them with a nice little whiteboard exercise. So that concludes today's presentation on responding to unauthorized configuration changes with opConfig and opEvents. I hope you found this of benefit. My name again is Mark Henry. That's my cell phone number on the board. Feel free to reach out to me. Also, markh@opmantic.com if you'd rather shoot us an email. And if you have any purchasing questions, you can contact the North American account executive Tom Wary at usa@opmantic.com. Thank you all very much for your time, and I look forward to seeing you again at a future webinar.